Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, this is the second video in the playlist on the AQA GCSE Maths, and it's the higher tier from June 2018, paper 2. Okay, in the previous video we completed through to question number 10, so we're going to be starting this time from question number 11. I'm going to aim for the video to be between 20 and 30 minutes in length. Okay, so this particular one, 2 ordinary fair dice are rolled and we're asked to complete the tree diagram. So the first dice, there is a probability of 1 out of 3 that the dice will land on a number which is less than 3. So therefore, greater than 3 would be 2 out of 3. Okay, and it's exactly the same with the second dice. We've got 2 out of 3, 1 out of 3 for less than 3, and 2 out of 3 for 3 or more. Okay, and then part B, it says work out the probability that both dice land on a number less than 3. Okay, both dice. Well, in fact, what we've got is a probability that they'll land on a number less than 3, which is going to be here, which is 1/3 for the first dice, and then the second dice is going to be 1/3. I'm sorry, that's gone off the screen a bit. So 1/3 for the second dice. So the probability that both dice will land on a number less than 3 is going to be 1/3 multiplied by 1/3, which is going to be 1/9, and that would be the answer to this particular question. Okay, on to then part C, and it says work out the probability that exactly one of the dice lands on a number less than 3. Okay, so what I'm interested in is this probability here, which is going to be the first dice landing on a number less than 3, and also this probability here, which is the second dice landing on a number less than 3. Okay, so this is where the first dice lands less than 3, and this is where the second dice lands less than 3. Okay, so if we look at the first dice, well, the probability of it landing on a 3 and then the second dice landing on 3 or more is going to be 1/3 multiplied by 2/3. So that's going to give me 2/9, and then I've got exactly the same with the second dice landing on a number less than 3, and that's going to be 2/3 for the first dice and 1/3 for the second dice, which is also going to be 2/9. So when it actually comes to filling out the second part of the question, I beg your pardon, part C of the question, it's going to be 1/3 multiplied by 2/3 for the first dice, and then for the second dice it's going to be 2/3 multiplied by 1/3. Okay, and when I work those out, I'm going to get 2/9 plus 2/9, and that's going to give me a total of 4/9. So the probability of me landing on or exactly one of the dice and landing on a number less than 3 is going to be 4/9. Okay, I hope that's okay for you. Let's move on then to question number 12. So question number 12, it says that a straight line is drawn on a centimetre grid. And what we're being asked to is to use the assumption to work out the gradient of the line, which is this particular one here. Okay, well, the gradient is going to be the difference in y divided by the difference in x. So if you can imagine, what I can do is I can draw a big triangle here. okay, and this distance here is going to be 4, and this distance along here is going to be 8, okay. So the gradient is going to be the difference of 4 divided by 8. Now, some people might say y2 minus y1 divided by x2 minus x1, and that's perfectly fine as well. It's no issue at all. Just for this type of question, I would say difference in y divided by difference in x. Well, that's going to be 4 over 8, which is going to be 1/2. Okay, so therefore the gradient on this particular graph is going to be 1 over 2. All right, let's have a look then at part B, and it says, in fact, the scale is 1 centimetre represents 2 units. Which statement is correct? Well, actually, the answer to part A remains the same. Now, the reason it remains the same is because both the y-axis and the x-axis basically just double, so it doesn't really matter. You're going to get exactly the same gradient. I hope that's okay for you. If you're not sure about how to work out gradient of a straight line, there is a playlist on the channel, and please do have a look at the playlist. Okay, let's move on then to question number 13. Question number 13 is being asked to show that when x is not equal to -1. Okay, that's all that means. When x is not equal to -1, that this simplifies to a particular form. So we are about halfway through the paper. The questions are going to get a little bit more tedious, a little bit more tricky to kind of work through, but hopefully you'll be able to follow me with this type of question. So the first one is I'm going to look at factorising the top and the bottom, and then I'm going to try to simplify it down. Okay, so the first thing is, if I factorise the top, well, I'm going to factorise that for 8, and I get 8x squared minus 1. All right, now be very careful about that, because where you've got x squared minus 1, you've actually got something called the difference of two squares, because the one that's in front of this x squared is a square number, and this one here is also a square number. So what I can do is, rather than writing x squared minus 1, I can actually rewrite that as 8 and x plus 1 multiplied by x minus 1. If you're not sure about that, just multiply this out, and what you'll find is you get to x squared minus 1. Okay, so the bottom, the denominator, well, that's fairly straightforward, and hopefully you can see I can factorise that for 4, and I'm going to get x plus 1. So what I end up with is, on the bottom, I've got 4 times x plus 1. And then really it's a case of just cancelling out in order to put it into the form of ax plus b. So the first thing I can do is I can cancel out the x plus 1. Okay, the two x plus 1s, and then if I divide top and bottom by 4, it means that I can make that 1 and make that 2. So actually what I end up with is going to be 2 times x minus 1. And actually that's the answer to this particular question once I've expanded it out, because I need to put it in this particular form. So 2 times x is going to be 2x, and 2 times minus 1, remember I'm just multiply this out, 2 times minus 1 is minus 2. So in this particular case, that would be my answer, and A equals 2 and B equals minus 2. Okay, I hope that's okay for you. Please do have a look at some of the other examples on factorising that are on the playlist on the channel, and that'll give you some more examples to have a go at. On to question number 14. Okay, so you will need a pair of compasses to do this. So I've been a little bit nervous about doing this on the video, but hopefully you'll forgive me. Hopefully it'll give you some idea, because essentially what I'm having to do is draw 2 circles. Now, one that represents a radius of 20 metres from P, and one that's 25 metres from Q. Well, hopefully you'll see that because each of the squares represents 5 metres, then from P I've got 4 along here, 4 along here, 4 along here, and it's actually just going to go up there. Okay, so I'm a little bit nervous about this because I'm having to do this freehand, but hopefully it'll give you some idea, okay, that I'm going to try and draw this circle something like, oh my gosh, I hope this is going to work out all right. It's gonna okay, it's gonna go something like that. Please forgive me, it's not the greatest circle, but please do have a go with a pair of compasses and you should be able to sort this one out. I'm afraid circle Q is going to be even worse because effectively from circle Q I've actually got 5 jumps, so that's 1, 2, 3, 4, 5. Okay, again 5 along the bottom, 5 over there, and then 5 over here somewhere. Okay, so again, let's give it a go, see if I can actually make this look reasonable. I'm not sure whether I'll be able to, but I'll give it a go. So we're gonna have a circle that goes like that and a circle that goes like that. Oh, that's not too bad. It's a little bit squashed, but it'll give you the idea. Okay, so effectively the bit that the water will reach from both sprinklers, the crossover bit, is going to be this central area here. Now, if you're doing this in an exam, please do use a pair of compasses, make it look a little bit neater than I've done. Okay, so let's move on then to question number 15. Now, question number 15 deals a little bit with something called box plots or cat whisker diagrams, okay? And what we're given is the median, the interquartile range, and the range for men and women who took a test. Okay, so using the data, which statement must be true? These are one of those questions, I know it's only 1 mark, but I think it is worthwhile just having a go at these, just to sort of see for yourself if you can kind of figure out what's going on. So what I'm going to do is I'm just going to very briefly draw a couple of box plots so you can see for yourself. So if we've got men, I'm going to do this off to the side because of the space. Okay, I've got a box plot that looks a little bit like that. Okay, now this is not drawn to scale, it's just a sketch. Okay, and what it tells me is the median is 28. It tells me the interquartile range is 7.5, okay, and it tells me the overall range is going to be 31 overall. Okay, let's contrast that with the women. Okay, so with the women, we've got, again, just a sketch of a box plot. Okay, so this is women. Okay, just a sketch there, and we're going to have a median of 30. Okay, we're going to have an interquartile range of 9, and we're going to have an overall range of 37. Okay, so that's going to be 37. All right, so I know it's not ideal, but at least it gives you some idea of what they're looking for you to highlight as the statements that must be true. Okay, so men have a higher average score. Average score is the total amount divided by the total number of men. Well, we don't know that because we haven't been given that information. Okay, a woman has the highest score. Well, again, we don't know that. We only know the range of both women and men. And a man has the lowest score. Again, we don't know these two for the same reason. We don't know that one. So men have more consistent scores than women. Well, that actually is true on this information because 7.5 is much, much closer in the interquartile range, and the overall range is 31 versus 37 or 9. So in this particular one, men have more consistent scores than women. Okay, hope that's all right for you. Please do, if you're not sure, have a look at some of the playlists on the website, on the channel, and there are some more questions regarding box plots or cat whisker diagrams. Okay, so let's have a look then at question number 16. So question number 16, we've got some concrete has a volume of that. the density of the concrete is that, work out the mass. Okay, so I had this conversation the other day with a student that actually I know that we do have some methods of teaching where actually you've got these kind of triangles here and you're expected to remember something like D, M and V. Okay, well, that's fine if you can remember that, it's not a problem at all. However, one of the other useful ones that you can look at is the actual density units are kilograms per meters cubed. Well, kilograms is a measurement of mass, okay, per is over, and meters cubed is a measurement of volume. So density, just by looking at the units, is mass over volume. Okay, now with all of these questions, you usually will get a unit that will give you a bit of a clue. Okay, so if you're not sure about where these DMs and Vs go into the triangle, then do have a look at a unit and see if that helps you. So I'm going to write density equals mass divided by volume. Okay, now let's have a look at what information have we got. Well, we know that the density is 2,400. And that equals to the mass that we're trying to work out divided by the volume of 3.8. Okay, now, just again, another little tip or comment about these is you've always got to make sure you're talking about the same unit. So meters cubed and meters cubed. And a favourite exam trick is actually to change those units around a little bit. So be very, very careful to make sure you've got the correct units in place. Okay, so if I want to work out M on my own, on its own, I'm going to multiply both sides by 3.8. And if I multiply 2,400 by 3.8, I get M equals 9120. So M is 9,120 kilograms. Okay, hope that's all right. Let's move on then to 16B. And it says the 3.8 meters cubed of concrete is made as the shape of a cylinder. The base is a radius of that. Work out the height. All right. Well, it's one of those questions where you need to kind of just think about how a formula works. Okay, well, volume equals area times depth. Okay, or in this particular case, if you want to call it height, that's perfectly fine. Well, how do we work out the volume of a cylinder? Well, we need to know the area of the circle multiplied by the height, and actually it's the height that we're looking to achieve. So let's put a little bit of numbers into this sort of formula. Well, the volume we know is 3.8. Okay, I can work out the volume, beg your pardon, the area by using pi r squared. Okay, now this comes up time and time again in these sorts of exams, so please remember the area of a circle is pi r squared, and then the circumference or the perimeter of a circle is going to be pi d. Okay, so pi r squared, let's have a look. Have we got that information? Yes, we have. We can say it's going to be pi multiplied, I'm just going to put a dot, by 0.5, and remember meters, okay, and meters cubed, keep it in the same units all the time, and that's 0.5 squared. Now the depth I don't know, but I'm going to call it h, which is what they're asking us to do, work out the height. Okay, so once I plug all of this into a calculator, I can then divide through by pi times 0.5 squared, and what I'm actually going to get is h equals 4.838. Now that's going to be in meters. Okay, so the height of the cylinder, which they're asking us to work out, is in meters, so that's perfectly fine. I'm going to leave it to 2 decimal places, so to 2 decimal places it would be 4.84 height. Okay, and that's if you like 2d P. All right, hope that's been okay for you. Hope you're able to follow that through without too much of a problem. All right, let's move on then to question number 17. What I'm going to do with question number 17 is I think that's probably going to be towards the end of this particular video. We'll have a look and see how we get on with this one. So question number 17 is a representation of a ball being thrown up into the air. Okay, so ball throws up into the air, and this is what happens. And then it says, for how many seconds is the ball at a height of more than 2 meters? I'm sorry about the video, it's just at the bottom there, the actual question, but if you do print this paper off, you should be able to kind of work through for yourself. So the height of 2 meters is going to be here. So if I just take that across, what I can see is between 0 seconds and 3 seconds, it was at a height of more than 2 meters. Okay, so the answer to this particular question will be 3 seconds. All right, and then it says, after how many seconds is the ball at instantaneous rest when it is in the air? All right, well, that's going to be at the point where the ball starts to then fall to earth because of gravity. Okay, so there is a point, and you can see it clearly on the graph. Hopefully it is this particular point here. And at this particular point, the ball has reached the very top of the throw, and then it's going to start coming back down to earth again. Now, hopefully you'll be able to see here that that is 1.5 seconds. So 1.5 seconds. All right, no problem. Let's move on then to part C of this particular one. Okay, and it says work out the average speed of the ball when it is moving downwards. All right, now you've got to be a little bit careful with this one, because effectively we're being asked to work out the time it's taking to move downwards, okay, and the distance that it covers. Well, the distance it covers is going to be fairly okay. It's going to be a distance of, from this point, which is 4.6 meters above the ground, through to 0. But you've got to remember that actually this particular one is over a 2-second period, because we're going to go from 1.5 seconds through to 3.5 seconds. So 1.5 seconds it's at its very height, and then after 3.5 seconds it lands back down on the floor. Okay, so if I want to work that out, the average speed is distance divided by time. And again, just to point this out, meters is a measurement of distance, per is over, and speed is a measurement of, seconds is a measurement of time. So speed equals distance divided by time. Okay, so S equals D over T. And again, if you use a triangle, that's perfectly fine, it's not a problem. But the distance it travels is 4.6, and the time it takes is going to be 2. So it's actually 2.3 meters per second average speed when it's moving downwards. Okay, I think it would be good actually, because it's the end of this particular page, to do question number 18 before we finish this video. So the solution of 3 to the power of x equals 300 lies between 2 consecutive integers. Okay, all right, so integer is just a fancy word for whole number. That's all it means. It's just a whole number. Okay, that's it. All right. Okay, and it's 3 to the power of something. So it's one of those questions where really you just need to use your calculator. So what you'll find, hopefully, is that 3 to the power of 5 equals 243, and 3 to the power of 6 equals 729. So the two integers, okay, are going to be 5 and 6. Okay, hopefully that's all right for you to be able to just finish this particular question. It's one of those 1-mark questions that tends to be slotted in from time to time. I hope it's been helpful. Please do add a comment if you're not sure about anything. I'll always come back to you. Please do have a look at the next video in this particular series, and I'll look forward to seeing you inside the next video.